Okay, we're going to do a video now on the different types of theorems. I don't know if you've been keeping up, but we actually have 4 different types of theorems. So the first type is just your regular plain old theorem. And this is any statement which is proven. So we have a lot of different theorems. We have the Aas Theorem, which says that you can make 2 triangles congruent if the corresponding angle sides are congruent. So that's one theorem. Another theorem we have is the exterior angle theorem. Both the strong form and the weak form. These are statements which we have proven to be true in the past, and we rely on them again and again because they come up in so many different proofs. The second type of theorem that there is there are things called propositions. And we have used this word since chapter 1. A proposition is a lightweight theorem. In other words, it can easily be solved in just a few steps. So in chapter 1, most of the proofs that we did were to prove propositions because we didn't know very much back in chapter 1, and so we had to have really easy proofs to do. So, so we chose to prove quite a few propositions. So an example would be if you look on page 46 of your book in Parkdale, you will see a couple of examples of propositions. So there is the proposition that if A, B, C, and D are on line L, and if C, D, E, and F are on line M, then A is also on M. Also on M. So here we go. A, B, C, D. But if we have C, D, E, and F are also on that line, then they're all on the same line. So you can see that, this is not rocket science here. It just takes a couple of steps. In fact, to do this proof in Parkdale on page 46, it only took us 2 steps. So think of it as a super easy theorem to prove. Then we have a type of theorem called a corollary. Not to be confused with a coronary, which is a heart attack. A corollary should not give you a heart attack because a corollary is a theorem that follows very easily from another theorem. So let's talk about corollaries for a second. So we have a main theorem called the AIP. It says that if alternate interior angles are congruent, then we know that the lines that form them are parallel, right? So if alternate interior angles are congruent, then we know that these 2 lines are parallel. Well, you can take that basic information and you can manipulate it a couple of different ways, and all of a sudden you have the PAI theorem, which is just the converse. It says that if you have parallel lines, then the alternate interior angles are congruent. Or you can have the CAP, which is exactly like this, except we're looking at corresponding angles instead of at alternate interior angles. So if corresponding angles are congruent, then the lines are parallel. So you can see that these 3 are all very closely related. If you understand one of them, you're probably going to understand the other one. That's what makes it called a corollary, is that it easily follows. The last type of theorem we get introduced to in Chapter 5, and it's called a lemma, which is my favorite just because I like the word lemma. So lemma is a tiny proof, or a tiny theorem that you prove to use in a big proof. To use in a big proof. So this is like a little baby theorem that you would figure out so that you don't have to write out, 18 steps in the middle of a more complicated proof. So let's take a look at an example lemma. And this comes out of your book. This is on page 176. Hold on. Having a little technical difficulties here. There we go. Okay, so page 176, we have a lemma that looks like this. So we have these two lines, and we have these, we've numbered our angles, and our lemma, that is our theorem that we are going to use, is if two lines intersect and form one right angle. So we'll say that this one right here is a right angle. And if we form one right angle, then all four angles are right angles, and they are all congruent to each other. Now, I'm not going to actually write out the proof here, but I'm going to talk you through it. So we have one right angle here, and we can see that 1 and 2 are linear pairs. So angle 1 and angle 2 are linear pairs. And so then we know that angle 1 and angle 2 are supplementary, and we know that angle 1 and angle 2 equal 180 degrees. So these two together equal 180 degrees. This one is 90 degrees, therefore this one has to be 90 degrees. We know that angle 2 is congruent to angle 3 because of the vertical angle theorem, so that one's also 90 degrees. We have 3 and 4 form a linear pair, so they're going to add up to 180. This one's already 90, so this one is 90. So in the end, you have 4 90-degree angles, and they are all congruent to each other. Again, this is a tiny little proof, but I would rather do it like on a separate sheet of paper like this and call it a lemma than stick the 8 steps that it would take me to prove all that into an already humongous proof. So that is what a lemma is. So just to go back and review, we have a theorem is any kind of statement which is proven. A proposition is a lightweight theorem, a super easy one. A corollary is a theorem that's closely related to another one. And a lemma is a tiny theorem that you use in order to make a large proof a little bit more manageable. Now, do you have to know, like if I give you a theorem, do you have to be able to tell me if it's a corollary or a proposition or a lemma? And the answer is no. That would not be important knowledge for you to have in your head. What I want you to have in your head is that these 4 things are all types of theorems. They are all proven statements that you can rely on in upcoming proofs. Okay, that's it. I hope you understand lemmas.